Today, we will cover the efficacy and applicability of 3D and AR visualizations in consumer product testing. Firstly, we will discuss the motivation and objective of this research, followed by the step-by-step implementation. Analysis will be done through statistical tests and data visualizations, and lastly, we will cover the significance of this research and conclusion. Firstly, motivation and objective. To give some context, interactive 3D is a form of visualization that allows users to view a 3D object in 2D space and even interact with it. On the other hand, augmented reality is a visualization that overlays these 3D models into reality itself. An example of augmented reality is the wildly popular Pokemon Go game. Consumer product testing is a method by researchers to ensure that a product's qualities meets the expectations and needs of consumers. A common type of product testing that may come to mind is QA testing, or quality assurance testing, where researchers test the product's quality and form to ensure that it does not have any quality issues. However, consumer product testing comes in many various forms. For example, concept testing is one form where consumer sentiments on a product concept is gauged. Another very popular example is A/B testing, where researchers test consumers' preferences across multiple designs. For example, Google tests different layouts, colors, and features on its search engine to determine which version performs better. In reality, almost every company we know uses some sort of consumer product testing. Different forms of consumer product testing are conducted in different manners. For example, a taste test of a new line of cereal would require a physical location for people. A website layout test, on the other hand, could be easily done online. Conversely, design testing for a logo could be done through an online survey. Ultimately, a controlled, centralized environment to conduct the test would be the most accurate. However, due to the time and effort in conducting them in such a manner, many companies have opted to do tests online if possible. Apple, Coca-Cola, and Nike are among many well-known companies that use online surveys. However, it is undeniable that online surveys come with certain limitations, such as limited participant reach, as well as technical issues. One of the main shortcomings that this research aims to overcome is the quality of a survey being affected due to the lack of physical product. When Coca-Cola does a physical survey on a new can design, participants can physically see, touch, and experience the product. But in an online survey, participants can only see the product through pictures, thereby affecting the ability to give accurate feedback. This issue is further exacerbated when the product is wearable. So for example, a picture of a pair of sunglasses does not let the participant know how it would look like on him or her. And this is where the incorporation of 3D and AR technologies can come in to help overcome such limitations. Moving on to the approach, a survey-based research is conducted. The survey implements a dual sequential monadic design. When the participant first visits the website, he will be randomly allocated to one of two surveys. The first survey is one that uses a wearable item, sunglasses as the product, and the second survey is a non-wearable item, which in this case is a phone. Note that participants will only do one of the surveys. Now, let's say the participant was assigned to the sunglasses survey. He will now do a series of questions evaluating the same product in different forms, namely 2D, 3D, and AR. For the exact survey questions, please refer to the report. Next, the analysis and results. Firstly, a two-step statistical test is conducted on the usefulness of the three forms of visualizations. Since we have the usefulness ratings of the three types of visualizations, we need to know if the probability distribution of the usefulness scores of the three are different. The fragment test is a non-parametric test that will test the null hypothesis that there is no significant systematic difference between the probability of preferring any one of the three different dependent designs. Simply put, if the null hypothesis is rejected, then we can conclude that there are at least 2 out of 3 designs that people prefer differently. And if we can reject the null hypothesis, then we know that there is a preference towards a design. As such, we have to conduct a pairwise post hoc test 3 times, namely between 2D and 3D, 3D and AR, and 2D and AR. If in any of these tests the null hypothesis is rejected, we can then conclude that people prefer one of the designs over the other. This same two-step test was conducted on the ranking question where people were required to rank their preferences as well. Now, for the statistical analysis on the usefulness, it was concluded that there was a difference in the statistical distributions of 2D and 3D as well as 2D and AR. Further analysis via data visualizations concluded that participants preferred AR and 3D compared to 2D, but there were no clear preferences between AR and 3D themselves. For the statistical analysis on preference, The results were also the same, except that we do not reject the null hypothesis for 2D and AR in the sunglasses survey. While statistical tests did not yield an exact conclusion, from further exploratory data analysis on the data, it appeared that people generally preferred AR over 3D when it came to interactive items, in this case being the sunglasses, while people preferred 3D over AR when the items were not interactive, which is the phone option. Due to brevity, data charts will not be illustrated, and you may view in-depth analysis in the report itself. The table below shows the reasons behind the top choices of participants for the sunglasses survey. For example, if you take a look at the first row, it means that 17% of participants that chose 3D as their favorite choice selected simple and easy to use as a reason for this choice. Similarly, 67% of participants that chose AR as their top choice in the sunglasses survey said that they chose it because it was simple and easy to use. The phone survey exhibited similar results. Lastly, the conclusion. In conclusion, the survey results exhibited strong support for the preference of both 3D and AR visualizations over 2D for both interactive and non-interactive products. While participants were conflicted on choosing AR or 3D as the top choice, no one in the survey chose 2D as their top choice. However, despite the clear distinction between AR and 3D against 2D, there is not as clear distinction between AR and 3D themselves. While there was not enough statistical evidence to show the differences in preferences, data visualizations did exhibit a noticeable difference or noticeable preference for AR over 3D for interactive products such as the wearable sunglasses, while the opposite held true where participants preferred 3D over AR for non-interactive products, in this case referring to the phone. Now, we therefore would recommend the adoption of both AR and 3D technologies for consumer product testing, and integration of such visualizations would not only enhance survey accuracy, but also improve user survey experience. People should use AR when the product is interactive, such as sunglasses and watches, but stick to 3D for those that are not. Further research on the usefulness of such AR and 3D technologies can be done both in terms of depth and breadth to support this analysis.